All right, we are live. Mic check. Everything good on your end, Susan? Okay. So we have a lot to talk about. Wow, and there's already quite a few people already on a live chat and also on YouTube. There we go. Yeah, looks busy. All right. So, and everyone's saying all good. So good. We have a lot to talk about tonight on a variety of topics, including the wintry mixed threat for Friday morning, and also the pattern overall, and where I'm seeing things are going. We're going to talk about the stratospheric environment and how that's interacting with the 500 millibar pattern, where I think that's going. And of course, I'll be taking all your questions, whether it's about whatever, the pattern overall, solar activity, whatever works for you guys. But I'm sure everyone's already interested in what they're going to be dealing with on Friday morning. So I am planning on walking through the observations of various models and explain what I'm looking at, and then we'll go over the forecast that was issued earlier on this afternoon on the map. So let's dive into this and make sure everything is up and running. And it is good. All right, so let's take a look at these observations here. And first of all, we have dropped a good 8 degrees since I sat down and started to break down the evolution of this threat and kind of go over some of the 18Z model guidance. We were around 62, 63 degrees at around about 6:30. And since then, we've dropped about 10 degrees down to about 54 around Belmar. Southern New Jersey's in the lower 60s, but already around northeastern Pennsylvania and around the Catskills and the Poconos, we're already in the upper 20s to lower 30s. So clearly we're starting to get some low-level cold air transport, but it's not incredibly strong here. And that is something that we really have to keep an eye on in terms of the forecast over the next 24 hours and seeing if there's any adjustments. The strength of the cold air transport over the next 12 hours is really going to tell the tale in terms of whether we're dealing with ice here, a lot of ice, or just kind of a brief period and we go over to rain. On the latest radar, this is our storm that's starting to evolve here. Not a lot of moisture, but again, when it comes to freezing rain and sleet, it doesn't take much to cause some problems. And that is clearly being experienced around Kentucky and around southern Illinois and Indiana. We have some snow here with a few moderate bursts also taking shape. This is all based on a shortwave in the subtropical jet stream interacting with this frontal boundary. And then here's our polar shortwave, which we can see really nicely here on the water vapor satellite picture. There it is, trying to dive in. There's our shortwave in the subtropical jet stream interacting with our southeast ridge. And we can see that pretty nicely here on our 500 millibar map here. There's our southeast ridge. And by the way, this is a nice indication of just how much influence we're starting to see from La Nina, although it's a weak influence when you combine this with the current MJO state, which is moving from phase 3 to phase 4. This is what you get. You get a storm track that tends to cut up towards the Ohio River Valley and then either tries to redevelop off the Delmarva Peninsula or heads up towards the St. Lawrence River Valley. In this case, it's going to track just far enough north and then jump off the New Jersey coast. Not enough time to keep cold air in the northern mid-Atlantic, but certainly for southern New England, it's going to lead to some snow and ice. It's going to be pretty significant. So we already see our 500 millibar pattern. It's pretty much all set up here. In the polar jet stream, we're starting to see the evolution of our upper level low / polar vortex influencing the convergence and confluence, helping to set up our surface high pressure system. So the surface dynamics are all in place here for a tricky forecast, to say the least, especially as that cold air is building in. And on the infrared satellite picture, you can see the influence of that lifting and the influence of the substance here with the clearing skies around Maine and the moisture transport down here around the southern plains into the Ohio and Tennessee River valleys. So let's take a look at some of the model guidance here. And what stands out to me is what's going on in the mid-levels, okay? On the newest European guidance here, it's pretty much showing the same thing in the GFS. This leading edge right here, this is our 850 millibar jet streak, and this is going to transport plenty of warm air in the mid-levels. So what can we take from this? Well, a colder solution is not going to lead to more snow. It's going to lead to more ice. Okay, this is either going to be a freezing rain event with a period of sleet, or it's going to quickly go over the rain, because the warming that's taking place at 850 millibars is pretty strong with this jet streak. The other little sign here is the fact that we have our 850 millibar low basically tracking over northern Ohio and heading towards Albany. That's a very, very warm signal. So the setup here is basically all or nothing for ice. In terms of snow, if you're looking for significant snowfall, you want to be in the leading edge here of this jet streak, which as we move through is basically around southern New England. So basically this area right here and to the north, which is why we're seeing a lot of model guidance converge on that. On the new HIR, let's see if this is loaded full yet. Nope, not yet. We'll come back to this because I want to take a look at the 0Z guidance and where it is on that respect. But let's take a look at the analysis here on the NAM. This is on Tropical Tidbits. And I want to take a look at various levels of the atmosphere on the SKU-T. So we'll start here in southern New Jersey. And you can see in this scenario, we're at 34 degrees. And this is, again, at around midnight. Okay, so southern New Jersey, the southeastern New Jersey coast is all rain at that point. Temperatures already above freezing. And this zero line right here, let me zoom in on this. This is your freezing line, 0 degrees Celsius, going up in the atmosphere. Okay, so over here, you have your heights. 500 millibars, 600 millibars. Here's your winds, and this is your freezing line. So what you do then is take this temperature and dew point line. Okay, it's red and green. Green is for dew points, red is for temperatures. And you see just how deep the cold layer is at the surface and the warm layer is at the mid-levels. Now, obviously, this is a rain signature right here, where your coldest environment in the rain section is basically from about, let's say about 925 millibars down to around 970 millibars. Now, let's go to a freezing rain signal, which is basically southwestern New Jersey at this point. And notice the mid-levels are pretty much the same. But it's the surface, that shallow layer of cold air, again, from about 925 millibars now down to the surface, that's our freezing rain signature. Now, why is this really important to me? Well, I'm not so much worried about like, oh, well, the model is saying this, so therefore the forecast should be that. What I am looking at here, and this is how you're supposed to use the model guidance, by the way, is the very, very small degree of error involved here between a significant ice event and just plain rain. This is a very, very shallow layer. You have an easterly wind in place here. You have a southwesterly wind just above the cold layer here. And then at the surface, you have a southeast and little weak northeast wind. Why is this important to me? Why am I looking at this? Well, what this tells me is that if you get just a slight shift of that wind more to the east than the northeast, then this scenario could end up being 33 degrees rather than 32 degrees. And that slight difference could mean the whole ball of wax in terms of whether we're dealing with a lot of freezing rain or just plain rain. And so this is why understanding the initial boundary layer conditions of this whole threat is going to be really, really important, and why tomorrow's 12Z guidance, heck, even the 0Z guidance tonight, I think it's going to see some significant adjustments, possibly to a warmer solution based on what I'm seeing with the 18Z trends, which would be great news for the morning rush hour on Friday. But this kind of tells us just how small of an error range that we have. Here's our sleet layer right here, and we'll take it to around Trenton. And what are we seeing? We're seeing the same scenario here. Okay, mid-levels, very warm. Okay, you're talking about roughly, let's say about maybe 5 degrees Celsius. Your freezing lines right here. Now the sleet area has a deeper, colder layer. That's why we get sleet. Okay, you get your snowflakes falling. They melt in this layer. They refreeze in this layer. So again, at the surface, you're at 31, 32 degrees, just barely below freezing. But your coldest layer is actually at 925 millibars. Now, why are we seeing this cold layer at 925 millibars? Well, let's pull up the guidance here, and we'll go to 925 millibars. Let's pull up the temperatures here. And we'll go to the NAM guidance. Let's see here real fast. Sometimes too much guidance. There we go. Okay, good. We'll go here. 925 millibar temperatures. Okay, so pull up 18Z. And what are we seeing around that time period for early Friday, around midnight? You see this thermal gradient right here? This is a sign of strong frontogenesis, okay? When we get in the middle of a storm, we start noticing where all our lifting parameters are. This sign here is what's causing the rapid cooling in the atmosphere to support that signature, okay? Where it gets very cold compared to the rest of the atmospheric environment at 925 millibars. So this tells us that this has to be driven, this sleet event has to be driven by strong frontogenesis. But it doesn't last very long, because notice an hour later, it's already rapidly pushing north and giving way. So this isn't sustained, okay? In the span from 35 hours, which is around midnight, to 39 hours, which is about 4 a.m., that frontogenical forcing is rapidly lifting north. So this looks like a very quick, heavy burst of snow, sleet, and freezing rain before it changes over to rain. So when we pull up the HRR guidance, knowing all these factors, we'll go to 18Z because right now it takes into account of everything for the HRR guidance. You can see what it's trying to do here. And the reason why I'm using the mesoscale models is because typically they have the best handle of the low-level dynamics. Sometimes it has some issues with convective feedback, but then you're trained enough to understand those limitations. And the trends we're seeing here is a rapid lift north. The warm air is winning this fight. And the only place where the cold air is able to put up a fight is basically southern New England. Now, again, you never take this stuff verbatim, but you take it as kind of a clue and say, okay, this is how the model guys are starting to see these factors based on all of the information we're gathering. And the NAM model guidance is basically doing the same thing. Okay, we'll pull up 18Z. And again, you can see it's rapidly moving in. The cold air rapidly is giving way. And by the way, part of this is because the surface high pressure system associated with this whole scenario doesn't have an ability to remain sustained. Now, why is that the case? Well, let's take a look at 300 millibar winds. Okay, so on Friday morning, let's actually, you know what, let's go to midnight. There you go. Okay, so your convergence and confluence is all starting to push over the Canadian Maritimes and points east. So this tells me that the support for your high pressure system is pushing east. And that's what allows your easterly wind, and that's what limits your ability to have a sustained cold air damming. I know a lot of people were kind of pointing out like, oh, the model guidance are going to underplay the cold air damping. And I would agree if I had a stronger support in the synoptic model guidance of a strong convergence and confluence zone. But because it's getting pushed east, that cold air damming is not going to have a lot of support in the upper levels to support convergence. And when you have that convergence aloft, it causes sinking. And that sinking air causes stronger high pressure because you're building up mass at the surface, which means higher pressure. So when I put all these factors together and combine that with the environment that's in place, for example, the fact that we were at 70 degrees, and while we are seeing a rapid cooling right now, the pavement's still going to hold on to some of that heat, so that's certainly a factor. And the fact that with the strong warm air transport, you're going to really limit your snow potential here. That's where I'm going with this forecast, okay? And again, I'm going to keep an eye on the guidance. I'm thinking that if anything, I'll probably end up going warmer than colder, okay? But for the coastal plain in this area, pretty much rain. Then you got this I-95 corridor area, which I think is going to be a little bit tricky, especially from about midnight to about 6 a.m., where you're going to get this period of snow and sleet changing over to rain, traced to maybe an inch on the roadways. You might pick up an additional inch on cold surfaces. Watching out for ice in terms of sleet and freezing rain for a short period of time. Because again, with ice, I want to make this very clear. With ice, it does not take much to cause problems. So if you think that, oh, it's only going to be a trace, that trace is all you need to slip and fall. So just be aware of that and use caution on Friday morning with that threat. Now, in this red zone and this red zone, this darker red zone, I'm very concerned about the ability for freezing rain to remain sustained. And here's why. This is based on experience. In these zones here, especially in this type of scenario where you have a relatively weak low pressure system, you have a secondary that's trying to develop off the Jersey Shore as the primary starts to weaken, sometimes you can get cold air, 31, 32 degree type air. We're not talking about brutally cold or anything in the 20s that would really cause a major problem. But you get just enough cold air locked into like Lancaster, Harrisburg, York, and you get the sustained freezing rain threat. So I'm putting that in for now, where you can get a tenth to a quarter of an inch of ice accretion, snow, a trace, maybe an inch at most on cold surfaces. But the ice is where I'm concerned about here. And the model guidance, some of it's picking it up, some of it isn't, but I rather lean on the colder side when it comes to an ice forecast, so that way you're prepared, rather than trying to be perfect and saying, oh no, it's just going to go over the rain, and then you walk out the door and you have a tenth of ice accretion on your surfaces, and you slip and fall and hurt yourself, right? We don't want that. We don't want accidents. So as we get more data to get a better idea of the cold environment here in locations to the north of Philadelphia, then I think we can have a better handle of maybe cutting this down. But for now, I think that's a realistic threat based on climatology and the nature of these type of storms. Then this area has been advertised for quite some time on the model guidance here. A lot of this is going to be sleet in terms of the snowfall here of that 2 to 5 inches. Okay, so this is going to be a snow sleet mix. Okay, the roadways, I think, still about a trace of 2 inches. Again, if you have any treatment on these roadways, it's going to save you quite a bit. But again, the freezing rain threat, where, yeah, someone could end up with a half an inch of ice on this. Now, understand, in these areas here, you have a lot of valleys where you can get cold air locked in. So you can have one area reporting 34 degrees, another area reporting 30 degrees, and you end up with a heck of an ice event right around I-80 or right around 476 here, Route 476. But I'm more concerned about I-80 here because you sometimes get cold air kind of pulling in here. and that could lead to some enhancement of ice potential. So those of you in northeastern Pennsylvania, I'd watch out for that. Same thing in northern Jersey. I'm very concerned about this area right here where you have some of the hillier ranges or mountain ranges here, kind of mountain ranges, and you can get some cold air settling in here and could cause some real problems. And that typically also shows up just north and west of New York City and right around Newark. You get this cold area here, the pools, and you're getting this heavier precipitation combined with the photogenesis we're seeing that could lead to a buildup of sleet and then a prolonged period of freezing rain before we finally go over the rain, say around 10 a.m. or so. And that theme continues on through the Connecticut coast. Now notice I'm kind of cutting this area short. I have the cold air wrapping in because once the precipitation shield gets to this point here, your secondary low pressure system is taking over and you are able to pull colder air into locations like the Cape. So in this area here, I still have sleet mixing in. The more sleet you get, closer you are to 5 inches. Not as much freezing rain threat here because I think the cold air holds on to mid-levels. But I think that the further north you are, the more likely to see that 10 inches of snow. And then much further north, you get that 6 to 12 inch snowfall threat, which I think is a significant concern as well. Massachusetts is in for some pretty good snowfall. Same thing with Boston. So that's how I see this storm. Again, if you have treated roadways, I think you're going to miss the brunt of this. And my hope here is that I'm too cold right now with this forecast. Based on the guidance I'm seeing slowly roll in, it looks like we're going to see some pretty strong warm air transport to mid-levels, and then the lower levels is a very shallow cold air with the brunt or the deepest layer at 9 to 25 millibars, which means that you could change over to rain and sleet, and then that rain isn't freezing because it might be 33 and sleet and rain. So you don't get that freezing rain, but you get the sleet, and then that sleet dissipates as the frontogenesis lifts northward. That's kind of what I'm hoping for here, but I played it on the colder side just so that way we were prepared for the worst case scenario and move forward from there. So beyond this storm, and again, I'm going to come back and take all your questions and everything on this threat. I want to touch on the polar vortex here because we've been seeing this, and I talked about this on the premium section this morning of what would be the influence of a split polar vortex, like what the European is showing here. Okay. The GFS ensembles, by the way, just creates this split, but same orientation and same focus more towards Russia. What does this actually produce for us? Well, some might assume that this is a cold weather pattern for the eastern United States, but it isn't. And the signal, and we learned about this in 2006, is this deeper upper level low or vorticity over Russia and heading towards China. When you see this split, what happens is that the polar jet stream reacts more to this than to this. So when you see this feature and you see this area here with heights building up, what you end up with is a very powerful ridge over the Aleutians and parts of Alaska, and that leads to a positively tilted trough over the western United States, which is all the model guidance is picking up. Now, here's the warning with this type of pattern. What you're going to end up with is a lot of Arctic air building up around Quebec and Ontario. And that leads a bit of a wild card in that what you could end up with is a storm track that cuts up towards the Great Lakes, and then an Arctic air mass gets pulled in. So through the middle of March, in this type of pattern, you're still going to end up with the potential for basically what we're seeing now. One day near 70, the next day near 30, and back and forth. So we're going to continue to still be a threat for these wintry mix, icy mix type scenarios here. This pattern is a significant risk for the interior for a lot of snow and ice. But for the coast, more of a wintry mix to rain type scenarios with a roller coaster type temperature regime where, like I said, one day you're near 70 and the next day you're around freezing. And this is where you just have to keep all your coats and all your clothes available, because one day you're going to feel like it's the summer and the next day it's going to feel like winter. So that is essentially what you're setting up here. And in this scenario, typically what happens is that the polar vortex reconfigures itself and solidifies itself for one more strong polar vortex centered over the North Pole. So I'm thinking that mid-March we're going to see another very mild sustained surge of Pacific air taking over the entire country at that point. But I do not see this pattern and this signal here supporting a widespread winter storm threat, because I know I'm seeing that a lot on social media. This is not a winter storm type pattern for the eastern United States, but if I was looking for a winter storm pattern, I'd probably look towards more like the northern plains, the upper Midwest, parts of the Ohio River Valley, especially towards Cleveland, and eastern Great Lakes too, Oswego, Syracuse, those locations. So I wanted to touch on that. So that is everything. Let me go back here. All right. So let me take some of your questions. Again, we'll first start with the premium chat, and then I'll take the best questions from YouTube chat, which, looks like we are very busy there as well. So we definitely have some good questions there. But first, of course, we'll start with the premium chat and go from there. Let's see here. Let's see. Oh, of course, evening, everyone. Speaking of the stratosphere, this is from Card. Speaking of the stratosphere, that is some warm pool. That is some warm pool east of Greenland at 10 millibars. Yeah, what we're seeing here is this transport taking shape here very nicely. Now, I'm seeing a very interesting change in the model guidance here, where for the first time in a while, we're seeing sustained transport to the northeast. Okay, this is more towards right towards the Arctic Circle, whereas this has been more towards the equator. So we're seeing a change in the winds here and the way that they're pulling, and we're seeing that change also showing up in the observations here. What's interesting, and let me pull this up here. Let me refresh this. There it is. Okay. Every time we see these surges starting to build, and this time we're starting to see one right around Greenland here. Every time we see this trying to push northward, because of the very cold nature of the stratosphere, and let me show you how cold it is. Actually, it'd be smart if I actually pulled up the data there. So again, duh. We have our northeast evolution here. There is our change I was talking about. So this is an interesting change in the structure of the transport. There is our wind transport that we're seeing right now, our EP flux. And the result of this transport is leading to the signal. Okay, where we had warm air first here, and now we're starting to see it warm up here. So what is the key factor here? Every time that we start to see this warming take place, whether it's around the Pacific or around Greenland, every time we see that it isn't able to expand. So this is why I'm questioning whether we actually see a full split in the polar vortex, as was shown on the European guidance, is because what I'd want to see in order to support that actual forecast from 10 days out is to see this warming spread throughout the higher latitudes of the stratosphere. And the reason why I'm very, very suspicious that that actually won't happen, if I can pull up the right data here, I know it's somewhere around here. Here we are, is this factor right here. We are well below normal. This is what should be normal in terms of stratospheric temperatures. Okay, when you're looking for a stratospheric warming event, you get this huge spike. This is the exact opposite. This is very cold air. And so that very cold air is going to inhibit the influence of the EP flux, which is why we just keep on seeing it stretching, which is why I am suspicious on the verification of that split idea. If we see this take hold and spread, at the very least over North America, then maybe that's possible. But I think it might be an error. Let's see here. Pretty impressive upper level low north of Leeward Islands. Yep, it's true. Let's see. Pavement and concrete cooked today for this time of year, near 70 in the urban heat island and I-95 corridor. Yes, and that's going to have a limiting factor, especially on your snowfall. The snowfall here that we're going to be dealing with is a very wet snowfall, about 10 to 1, maybe 8 to 1 ratio. It's also going to be mixed with sleet, especially for those of you in Connecticut. So that's going to be a limiting factor as well. I think that we're going to see in this storm more reports of snowfall accumulating on cold surfaces rather than the pavement. The one negating factor against that warming issue is that we're also going to have this happening early in the morning before the sun rises. So as a result, you might be able to negate that factor to some extent. That leading edge frontogenesis is going to make or break the entire forecast in terms of snow accumulation for the northern mid-Atlantic. Not so much for New England, where we're expecting 5 to 10 or 6 to 12 inches. I could certainly see a scenario where a lot of the northern mid-Atlantic in this forecast area ends up below the snowfall forecast, maybe an inch, because of that warming factor and because of the progression of our frontogenesis. And then just to the north, like let's say New Haven ends up with an inch and let's say about 1/10 of an inch of ice. And then just north of New Haven, you have 5 inches of snow. I could definitely see that type of gradient setting up. Expect the Mount Pocono saucer dish to get some solid icing. Yeah, I'm very concerned about that. That 1,800 to 2,000 foot high saucer dish is a perfect spot for icing. Exactly, and that's kind of what I'm playing up here, and other areas also being set up. What will you be looking at as terms of timing, strength, location, or the secondary low? The secondary low is going to be a very minor feature, and let me pull up and show you why I think that's the case. We'll pull up 500 millibar vorticity. And in this scenario, all your strong lifting is towards the eastern Great Lakes. Very, very minor lifting, and not much in the way of divergence and diffluence either, stretching or spreading of the heights here. So your secondary low is not going to be a significant factor here in this storm development. And let's just go right to the pressure field here. In fact, let's see if we can zoom in on this. Perfect. Okay, so in this scenario, you're talking about 1,018 millibar low. There's your high pressure system. This is all on Friday morning. Notice our Cade signature is not very strong. It's present. That's what leads us to our ice potential, but it's not very strong. And it quickly moves east. Look at the difference here. Okay, there we are at 7 a.m. Here we are at 1 p.m. That high pressure system is gone. It's booking east. And our low pressure system, it goes from 1,018 to 1,000 millibars as it jumps towards the coastal waters. Sorry, let's see. 1,010 millibars. So it drops about 8 millibars in a span of 12 hours. Or should I say 6 hours? Not exactly very impressive. Okay, so this is not a strong secondary surface low. It really doesn't take over until we get to about New England, where we get that cold air gets pulled in. Let's see here. Oh, we still have a lot of questions. All right. So the Friday morning commute may be more wet than icy. I still use extreme caution if you're north and west of the I-95 corridor. But I think if you are along and south and east of the I-95 corridor, I think it will be, especially south and east, I think it'll be more wet than icy, to be honest with you. Especially like around locations like Freehold, Belmar. Atlantic City is definitely going to be wet. Camden, I think it's going to be more wet than icy. Philadelphia, New York City, right around that little stretch, right around Trenton, it will be a bit slick. Watch out for some icy spots, but the worst is going to be north and west of there. If there is no full PV split, could it result in less of a PV going towards Asia and more staying over the poles or sliding a bit towards North America? Not towards North America, not in this scenario, because of the orientation. Even in the GFS ensemble guidance, let's see. We'll pull up this one right here, and we'll use 12Z. I never like to use 18Z to justify a synoptic scale because we don't have new data at that level. But take a look at what the GFS is trying to do here. It stretches it, but never closes off a split here. It never does a true split here. Just a very strong stretching. But notice your strongest heights are all, your deepest below normal heights are all focused towards Russia. So this is a signal here where you get your cold air focus, actually really pretty much focused towards the Canadian Maritimes in this flow here. Whereas what you want to typically look for a cold weather pattern for Eastern North America is for this to stretch more towards, let's say, the Hudson Bay. That way you get your transport from Siberia right into the northern plains, and then that gets transported towards the East Coast. When you have this type of scenario, and again, not much of a difference, it's just a slight shift. This right here transports your coldest air towards the Canadian Maritimes, and it also leads to a trough at 500 millibars somewhere on the west coast around the Rockies, because this heights here, these heights here in this ridge is building. And so that's what we're seeing here in a variety of guidance. Let's take a look at the GFS ensemble guidance here. Where are you? There you go. And it's pretty much showing the same thing. Again, we'll go to 12Z here. And let's go to 240 hours. There's our ridge. There's our resultant trough. There's our influence from the polar vortex split or stretching. Notice this leads to building heights over the eastern United States. And as we move forward, you get that signal even more. You get more your below normal heights around the Canadian Maritimes, a focus more towards northern Canada. This ridge, what you end up with is kind of this Rex block here. So you get below normal heights over the west coast here, and you get this Pacific weather pattern, Pacific influence in terms of our air mass cutting through the Rockies and towards the east coast. This signal here with downsloping off the Rockies will lead to a pretty warm air mass for, let's say, around the March 10th, 11th period for the eastern United States, while all your Arctic air is trapped up here in Quebec. Let's see. I was hoping to get up to Tug Hill area. Been there, a lot of fun, for snowmobiling, but seems like most areas only have a trace to 8 inches on the ground, even in rainfall. That's unusual. Wow. Is there anything in the pattern that would give hope for some decent snowmobiling up there? Not really. I mean, in this pattern, if you can get the cold air to sink just enough and you get a storm track to the south and east of Syracuse, you might have a shot, but really, no. Certainly not any lake effect events to really add up there. Not looking very promising right now. For the secondary low, I was thinking more surface winds influence rather than strength of precipitation. Yeah, but the problem is that the primary low pressure system in this scenario, and we'll pull up the winds here. And let's jump to Friday. Let's say right around midnight. See that wind influence? Due east. This is murder. Anytime you see an easterly wind, it is murder for frozen precipitation forecasts. This is a big warning sign if you try to support a deeper snowfall forecast. let's say trying to push it, let's say at 4 inches or something like that around New York City, this is a big, big, big warning sign against that. And that is at the coldest part of this storm. Now, there's our secondary low pressure system forming, but notice the winds are still from the east because your stronger low pressure system's here. Your secondary is just starting to get its act together here. So you still have an easterly wind, and your thermal gradient or thermal transport is still coming due east from the Atlantic Ocean. Now, moving forward, once we get to about the afternoon hours, we start to see this become even stronger. And notice towards the evening when we're seeing our transition of snow and sleet rather than rain, notice the winds are more coming from the north and the northeast, which keeps this area colder, which we don't have over the northern Atlantic during this development. Let's see. Gregory Gorin asks, you just mentioned not using 18Z data for certain things. Is there a difference between 0Z, 06Z, 12Z, and 18Z models? Is one more reliable than the other? Okay, so it kind of depends which model you're using, okay? And what you want to do, you want to go to the NCEP website, which is, let's see here, this one right here, wpc.ncep.noaa.gov discussions, okay? Extended forecast discussions. And that gives you the ability to take a look at the model data error, okay? Guidance evaluation. And it tells you whether or not you have any error in the guidance in terms of data input. But the 0Z and the 12Z guidance gives you the best potential of ingesting as much observational data as possible and also correcting errors. The 06Z and 18Z guidance has limited upper level additional input. This isn't always the case. Like when you start hearing the potential for the National Weather Service sending planes in, sometimes they ingest that into 18Z guidance. Most times they wait to the 0Z guidance to ingest it, or 12Z guidance. But the 06Z and the 18Z guidance, what that does for you is gives you a chance to say, okay, if there was an error in the 0Z guidance, let's say that some bad data was put in, or there was an error in the convective feedback, in the convective latent heat release equations in the guidance, does the 18Z or 06Z correct that error? And if it does, then what is the result of that correction? Also, you can use 18Z guidance better for mesoscale models, because mesoscale models, you're looking at low-level data, and you can ingest the latest low-level data, which is basically your observations, your surface observations. So it allows you, like if you have the HRR, if you have the NAM guidance, although I don't always trust the 18Z NAM guidance, it can at least give you in that 12-hour ballpark a better idea of what is evolving and what might be changing in the surface dynamics. So much like with many tools, there is no hard answer, okay? Statistically speaking, the 18Z GFS is one of the worst performing models that we have, okay, statistically speaking. The best performing model guidance is the 0Z and 12Z European guidance. Then the GFS comes second, and then the Canadian guidance. That should not be your one and only primary evaluation of model data, but it kind of gives you a good starting point, okay? So your 18Z guidance is something that you use as a comparative. You never want to change a forecast based on 18Z guidance. What you can do is take a look at the 18Z or the 06Z guidance and say, okay, models may be moving in this direction. I need to understand why it's doing that and prepare a forecasting idea based on that. And then that way you can make adjustments on the 12Z guidance depending on whether or not you trust that evaluation. Also, it's good to know, based on what's happening in the mid-levels, how does the model come to that solution? Is there an error in phrenogenesis? Is there an error in the way that the model guidance is handling upper-level wind dynamics? But at the end of the day, It really comes down to you understanding what are the current observations and how well do they match up with the model data that you're looking at. Does the anticipated pattern for mid-March raise severe threat concern for our area? More heavy rainfall than severe thunderstorms, I think. I think that the Tennessee River Valley and the mid-Mississippi River Valley are in line for some active severe weather. I think we'll get into that act more towards May, but that could change, okay, depending on what I'm seeing. But it's kind of ballpark what I'm thinking in terms of severe weather season and whatnot. Um, a lot of that has to do with the evolution of La Nina and the strength of the subtropical jet stream, but also the evolution of the polar jet stream and what happens. So let me go take a look and see what we got on YouTube. Holy smokes, we are busy here tonight. Thank you also, all you guys watching on YouTube. Really appreciate it. Let's see here. Just wondering what changed. All right, so MN Cards asks, this is a good question. A couple weeks ago, you said a Pacific flow after the 15th of the month. Just wonder what changed. Nothing. How do you think we got to 70 degrees? That is because we're seeing a Pacific air masses marching across. Let's recap what I was saying during that time period for the middle of this month. I said that the cold air masses would be transient. They have lasted about 1 to 3 days. And then we'd get a warm surge. It'd be a roller coaster, which is what we've been seeing. And this is what's always really a troublesome aspect in terms of when you're talking about anomalies and forecasts. We've been featuring below normal days, but our above normal days have been way above normal to the point where we're seeing record high temperatures. You're talking about temperatures in the 60s and 70s, and then we fall off and fall back into the 30s. Now, how long is this cold air mass lasting? Basically 2 days. Well, maybe 3. Okay, well, I had 3. Thursday, Friday, and half of Saturday. And then we're already rising, and Sunday we're getting closer to near normal. So the polar air masses and the Arctic air masses have less and less of an influence. And the Pacific air masses, which warm when they go over the Appalachians because they're getting subsidence, it basically comes down off the Appalachians. And that's how we're getting these very, very warm days. We're not seeing a lot of air masses from the Gulf of Mexico. We are seeing some influence, but not a direct impact. But we're definitely seeing a significant influence from Pacific air masses marching across the coast, across the country. And there are polar air masses where we used to have that direct flow coming in from northern Canada and Siberia has essentially been severely stymied and limited in duration and time period. Let's see here. 5 to the next 10 days. Is it just my phone or is the screen resolution a little fuzzy? It might be your phone. Although I wouldn't, I don't know. Let's see here. What are the visual differences between freezing rain, ice, and sleet? Because sometimes it's hard to identify what is what. Do you mean on a model guidance or just in general? Freezing rain, okay. I actually seen this once. If you take a donut, right? A glazed donut is basically a great example of freezing rain. Okay. A donut with like sprinkles on it, that's a good example for sleet. And then a donut with coconut on it, you know how coconut can be, that's a great example of snow. So that is, and ice usually falls under the characteristics of freezing rain and sleet. Now, you're asking someone who's colorblind, which is probably not the best thing. The differences between the map features for sleet and freezing rain. Typically, sleet is shown on model guides and on maps as either a salmon red or an orange, and freezing rain is typically shown as dark red. At least that's what I've been told. Let's see here. How does a warm day like today have an effect on accumulations on Friday? Warm days like today have a stronger impact on asphalt, where you can retain that heat, and also concrete, rather than grass. Okay. In terms of grass and car tops, you could cool down a boundary layer a lot faster. But the asphalt takes time. Now, if you get strong lifting where you get very heavy precipitation, that heavy precipitation can cause rapid cooling, and that rapid cooling can overcome the warm asphalt and lead to snow accumulation, which is why we're keeping a very careful eye on that 700 millibar frontogenesis and that burst of heavy precipitation. Let's see here. Oh, all right. Let me answer this real quick. Do you think, do you think Central New Jersey on south of New York City can end up with 2/10 of an inch of ice? If you're talking about Monmouth County, I don't see that. Middlesex County, maybe the northern portions, but it's going to be really hit and miss. As I said, in this scenario right here, about 2/10 to a half an inch of ice. I think that's going to be more potential up here than down here. But I would be very careful if you're around I-78 and I-80. I'd be very careful on Friday morning if you're traveling. Okay, back to the premium section. Let's see here. Major flood concerns for March. I think, and I've been watching the water tables, and we're not too bad. Okay, it's not anything excessive. What I'm concerned about in this type of pattern, and I guess I should pull up 500 millibar map here. This time we'll go use the European Ensembles map. Okay, and we'll jump to 10 days out. 10 days out, what does this translate to? Well, in this scenario from day 10, which is basically the morning on March 5th, and we'll go all the way to March 10th. What this typically leads to is that with this ridge here, basically over the southeast and back towards the Bahamas and around the Atlantic Ocean, this leads to a pretty healthy moisture transport from the Gulf of Mexico that runs into a cold front because of this structure here, which is your positively tilted trough. Now, this signal of a positively tilted trough means that upper level winds typically run parallel, not perpendicular, but parallel to the surface front. And we see that really nicely here on the 300 millibar winds during the same time period. I'm going to pull this up. And you see this signal right here? This is a pretty strong signal of slow moving cold front boundaries and waves of low pressure. So if you have a pretty good sustained moisture transport at 850 millibars, and you have this feature here, and in fact, let me see if I can pull up 850 millibar winds. There we are, perfect. In this same scenario, there's our 850 millibar winds. So our upper level winds are parallel to our surface cold fronts. There's your transport of cold air transport, which is pretty weak. And here's your stronger moisture transport coming in from the Gulf of Mexico. The combination of these two with convergence and confluence at the lower levels leads to your potential here for above normal rainfall, and the potential for flash flooding. We would need several heavy rainfall events for us to reach that point for mid-March. Right now, I don't have guidance to support that solution, but if I was looking for a pattern to get us there, this would be it. Okay, so that's why I said in the discussions today, especially for everyone who read the premium long-range discussion, this could end up being a rather wet pattern for basically the Tennessee River Valley going right up into the mid-Atlantic. Okay, not bad. It's already 8:55. Wow, we've already had a wonderful chat. So I'm going to take a couple more questions and then we're going to shut it down for the night. Again, just kind of going over while I'm waiting for a couple of questions. Let me see if I got new guidance in for the HRR guidance, because we were waiting for that. 0Z guidance. Let's pull that up. Let's see what it looks like, and we'll walk us through that. And then if you have any other questions, I will be happy to answer them. So let's see here. We're marching our way through. Okay, so the HRR guidance, 0Z, notice it's already going with a warmer solution here over central and southern New Jersey. Those of you around Trenton, you would be happy to see this. You're already going above freezing with rain. The concern I've had here for southeastern Pennsylvania is showing up very nicely. Now this area is more sleet than snow. Okay, again, this is your 2 to 5 inch area here. It's going to be heavily mixed with sleet. Here's your freezing rain threat. This is a good sign for the I-95 corridor and being warmer in this solution. We go over the rain faster on the new HRR guidance, while it's really just an icy mess north and west of the cities. And the good news is that also, and one thing I was watching out for, let me see if I can refresh this real fast. Okay, this is moving pretty fast. So this is also having this moving faster, where a lot of the guidance was having like precipitation linger until about 6 to 8 p.m., especially around Connecticut and Long Island. Now the HRR guidance, and I want to back this up and take a look at NAM and the European tomorrow morning, along with the GFS, to see if this holds true, where this whole precipitation event is already over by 2 o'clock, which could also cut down on your ice potential. So in this scenario, let's take a look at what it's doing with snowfall here. And it's pretty close to what the going forecast is. Not too far off. Not much in the way of snow. A lot of this is going to be mixed with sleet, and all your heavier snowfall is up here. So the new HRR guidance is not far off from the current forecast. And then you got your freezing rain threat here around Lancaster, Harrisburg, so on and so forth. So the forecast, the HRR forecast, is almost a carbon copy of what we have forecast here. And then we'll see how the rest of the 0Z guidance plays out over the next couple of hours. So that is essentially our discussion for tonight. I hope I answered as many questions as I can for you guys. We will be back again next week and possibly talking about more warm weather. Maybe we'll talk about more thunderstorm potential and also some other questions as well. But I think that we're definitely moving towards a pattern that is going to be more warmer than colder. We still have our shot for some cold waves, but if you're looking for wintry precipitation, this is a pattern that's going to be more supportive for the Poconos and Catskills rather than the coastal plain. So again, I want to thank you again for joining me, and I really appreciate it. And as always, stay safe out there.